Hello again, this is Scott Hamlin, CPSC 2100 class. This is the screencast for problem set 2. Problem 3, bisection search to make the program faster. My screen on share, and we're going to go through this problem. It's not too difficult. What we want to do this time, we want to do the same thing we did in problem 2, except this time we want to compute it to the penny, what the lowest payment is, and we want to use bisectional search to make it faster, because this is a lot more precise than trying to do it by tens. So let's get right into it. I'm going to assign X $5,000. Okay, and what this is variable to assign starting balance. I'm still going to use balance, and that's going to equal X. Okay, so you can go in, if you want to change the parameters, you can just change X. Still going to use balance. Okay, annual interest rate, that's what we had before, 18%. Our monthly interest rate equals our annual interest rate divided by 12.0. Okay. Now we want to set upper and lower bounds since we're doing a bisectional. So our monthly payment upper bound is going to equal, good starting is balance times, and thanks for the formula. I couldn't really come up with this on my own. I have these memorized, these good interest formulas, but monthly interest rate plus 1, so, and then we're going to raise it to the power of 12, and then we're going to divide that by 12.0. Okay. And then our lower bounds, monthly payment lower bounds, is going to equal our balance divided by 12.0. So that should get us pretty close. We know that our lower bounds, that is not going to pay off the balance, as we saw in our last process. And then the monthly payment upper balance, that's what that is, just, hey, charge me all the interest on the balance, and I didn't make any payments all year. So you know that's going to be, it's going to be a high payment that you got to make. Okay, so you get that computed and then divided by 12, so that's going to be too much. So we'll start our while loop. While monthly, and our basically, I could have used epsilon, but I didn't think about that. I tried to do most of this from memory, and that's not necessarily always good. But we want to basically take, what is the difference? When we know right now monthly upper payment and lower payment isn't going to meet our factor, but what we want to do is get those two numbers back and forth, and our epsilon for this is 0.01 cents. Okay, as long as they're within a penny. I could make that actually 0.0. I was thinking, yeah, if you subtract the two of them, and they're exactly a penny off, it's still not the right answer. So let's make that 0.9 or 0.5. Okay, that makes it a little closer. Just thinking this out. 0.01. You could have a penny difference. Is that close enough for our things? Let me just keep it the way I had it. Okay, we'll just keep it to a penny. Okay, within a penny, that should be enough. Okay, balance equals X. That's how we started off, and so our while loop will keep going until we get those two payments to within a penny, and that'll be our answer. So payment equals monthly payment UB plus. So here's where we're taking our upper and our lower bounds. We're adding them together. We want to get the middle, the median. okay? So that will be our payment. We know it's not the higher, it's not the lower, so let's just start in the middle for doing a bisection. So we've gotten our payment. Then we'll start our iterations for I in range, in our typical range of 12 months, okay? We're gonna do these formulas, which we've seen before, which is basically removing from our balance the payment, and then every month you need to increase your balance after that payment by the outstanding balance times the interest rate. 0. I need to be consistent here. 12.0. There we go. Okay. Still don't know how I want to do this in the future. Keep everything spaced together or not. Okay, so we've done iterations. Now we need to do our checks. If balance greater than 0, what does that mean? If our balance is greater than 0, then our monthly payment was too low. So, it's too low, so that we want to take our previous payment, make that our lower bounds. Okay, we don't want to go any lower than our payment we were making. Okay, so that's going to change the lower payment to what we were paying. So that's going to move the range. Now, if it's not that, then obviously our balance was less than 0. So our upper payment was too much. So we want to adjust the monthly payment, upper bounds, make that the payment. Okay, and then this loop will go, that's the end of this while loop. It's going to go back up. It's going to go, okay, now you've got a new, let's just say you've got a new lower payment. Your lower payment, what your upper payment was minus your lower payment. Is that greater than a penny? Most probably it will be, okay? So we want to, the reason we have this whole balance equals X is I want to go ahead. I could have probably could have put 5,000 would work just as well, you know. I didn't need to use the X variable. But regardless, yeah, I probably could have done that instead. So your balance is 5,000. Now we're going to go through our same loop, and we're going to keep taking that lower and upper and squishing them together until we can get a difference between those two to just a penny. And once we exit this while loop, I want to print out lowest payment, and then do our formatting magic here. CF, all right, and dot format. I want to round the payment, and we're going to round it to 2 decimal places. So this time we give it a +2, and that should work. Let's see what happens. Lowest payment, $451.62. Okay, we just want to see if it's working. Let's say if we made the annual interest rate only 0.16, we would figure the lowest payment should go down with the lowest interest rate, right? 451.62, and it does, 447.69. So I believe I've got this correct, and yes, it works. So thank you for your time, and I will get this published.